Hey, welcome to part 2 of the Chris and Jim Sim Manufacturing Statistics and Math project. Today we're going to talk about measuring the candies, and what we're going to do is check and see all the different sizes and compare them from color to color and all of them together. So this is the page that we're going to do it on. This is the third tab called the diameter tab. So if you click on the diameter tab, open up your spreadsheet, click on the diameter tab, you'll see that I've already put a little bit of data in there for you. We're going to do one color together, and then the rest you're going to kind of do on your own. So if you remember before, I took all the M&Ms, sorted them by color, and then I used a set of calipers. This one happens to be digital because it's the only one I have home. And I used the digital calipers and I measured 20 of each of the different colors. Yes, I measured them for you so you can at least just go and type the information in. And I'll show you how to do that too. So I measured 20 yellow M&Ms with my calipers, and this is the data that I got. In my spreadsheet, I want to know mean, median, and mode, and I also want to know the standard deviation. So there's all my data from the last part of the activity. You should be able to figure out how to put those in there. Remember, you use the formula up here, pick the right formula, put it in the box after choosing all this data, and you're good to go. We're going to learn a few new tricks too. So let's do this. Let's take all of our data and let's put that data in order. So to do that, what we're going to do is we're going to go to Sort and Filter. Click on Sort and Filter and choose Custom Sort. Because we're trying to sort a row, we have to do it with custom. It gives us a warning and it asks us, hey, you only picked part of the row. Do you want to pick the whole row? And the answer is no. I want to use the numbers that I picked. So continue with the current selection and say Sort. Then choose Options and make sure you choose Sort Left to Right. Usually Excel is used to doing stuff in columns, not rows. So we have to tell it we want to go from left to right instead of top to bottom. And click on OK. And then choose row 5, cell values, smallest to largest, and say OK. And as you can see now, all of your numbers go from smallest to largest across the row. Awesome. Now, what we're going to do is we're going to take this data, we're going to put it into a little table down here. And this little table, what it's going to do, let me see if I can add another column so we've got some space so we can see. So we've got the yellow candies. We're going to do the yellow candies first, and we have to put them in here. We have to put the mean in, and we have to put in what the different sigmas are. So remember, mean, let's put the mean in this box. So what I want to do is choose my mean from box X5. That's cell X5. So what I want to do is I want this box to be equal to what's in X5. That way, if my data changes later, if I go and I measure some more and that number changes, this number changes with it. Makes it parametric. So I click on Enter after I hit the equal sign, and there's my mean, right? So now I have to add 1 sigma to it above. So I'm going to go look at my standard deviation, and my standard deviation is 0.000963. So I see that that is cell AA5. So I'm going to go back over here and say that I want this box to be equal to the mean plus what's in cell AA5. Oops, be careful. And hit enter. There's my number. That way, if anything ever changes, these numbers will change with it. Makes sense? So I'm going to make this a little bit easier on everybody. We're going to take this, Control X, slide it over here, Control V, and then that way we can see the whole shoot match. There we go. So what do you suppose is going to go in here? This has to be mean plus 2 sigma. So in this box, it's going to be equal to this plus, in parentheses, 2 times, that's an asterisk, shift 8, times the standard deviation again. And I just clicked on it that time. Oh, found a typo. It says, hey, you didn't put the last part of that equation in. You want me to do it for you? Yep, sure. Thanks. And then what's this one going to be? Can anybody tell what the equation is going to be? Put your equal sign in. Mean plus 3 times what's in this box. Enter. And again, go down here and we're going to say this is equal to mean minus 1 sigma. No parentheses needed. And this one is going to be equal to this minus parentheses 2 times sigma. And this box, again, is going to be what? Minus 3 times sigma. And my parentheses. Oops. No, let's go fix that. I forgot to put this parenthesis in. There we go. All right, easy. Now, the reason we put these in order was because we have to take all of these and put them in the frequency. So we need to know how many of these measurements fall between these two numbers, how many between these two, between these two, between these two, and between these two. So we have to take all these numbers and account for them in this frequency. So we're just going to count, okay? So now the question is, how many of those numbers in the row above go between 0.502 and 0.512? So let's take a look. 0.51, 0.512. So there's only one. So that's that first number goes in that box. The next box, how many are there between 0.51 and 0.52? 0.512. Let's do this. Let's make these. Oops, wrong way. Let's just make them go 3 decimal places and make it a little bit easier on us, okay? So what's between 512 and 0.522? So 512, and that changes everything, doesn't it? Now I can see my data a little bit better. What numbers do I have between 0.503 and 512? 503 and 512, I still only have one. Yep, that was right. Good. Better to check yourself when you're doing statistics. Now, how many between 512 and 522? 1, 2, oops, just 2. So I'm going to put 2 in that box. How many between 522 and 532? That's 1, 2, 3, 4. Does that one? No. So there's only 4 in there. How many between 522 and, I just did that one, 532 and 541? 532 and 541. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, there are 9 of them right there. And between 541 and 551, 541 and 551, there's 3. And that's all of our data. So this is 0 and this is 0. Just to make sure, I'm going to do an auto sum on those. Ooh, I missed a piece of data. You see how I've only got 19? So the question is, where did I miss it? So let's take a look real quick. 503 to 512. 1, 512 to 522. 2, 522. 5. There it is. There's an extra one there. Let's put that in. Okay. Now we've got all 20 numbers. Now all we have to do is make a histogram of this and figure out what it means. So I'm going to select this information. Notice I selected the titles too. I can choose Insert, and I can go to my charts, just like I did in the last unit. And I'm going to pick my 3D column, and I'm going to place that down here. Notice this is my yellow candies. If I right click on this and choose the fill to be yellow, I can make them yellow, and then I can say that's my yellow candy. So there's my data. Now the question is this good data? What does it mean? Okay. Well, if I take a look at this, it means that I've measured 20 M&Ms. If I measured more M&Ms, I think my graph would look a little bit better, but what I'm shooting for is, shouldn't most M&Ms, when you manufacture a product, shouldn't most product be exactly the size they're supposed to be? Let's call that the mean, right? So if we're shooting for this size, 0.532 in manufacturing, we're going to have some that are a little bit smaller, and a little bit smaller, a little bit smaller, and some that are larger and larger and larger. Now M&Ms don't have to fit together in an engine like a piston and a cylinder. So the amount of the standard deviation is going to be less on parts like that than they are in M&Ms, but we can see the same thing. Shouldn't most of our parts all fit, all be the same size, right around where we want it to be in the mean, right? So look at that. The M&Ms, most of them are this size. Some of them are a little smaller, some are a little bigger. Very few are much bigger still, and there's a few that are much smaller. So there's some tiny ones, but if you take a look, it's shaped like a bell curve. And that's really what we're shooting for when it comes to manufacturing. We want most of our parts to be the right size. And then your manufacturing process, if these numbers start to grow, or these numbers start to grow, there's a problem with your process and the way that you manufacture stuff. And you can't have that, especially if you're manufacturing to Six Sigma and for car manufacturers. You really want to focus on getting your product all to be about this size. You're always going to have a few smaller, you're always going to have a few larger, but we're talking thousandths of an inch, or 10,000ths of an inch when we're talking about auto manufacturing. So your job now is to use this video to do the rest of this data, fill in the rest of this table, make these data charts for every one of these colors, make a histogram for each of the colors, and then answer these questions here. Once you're all done, you're going to submit it to your instructor. They'll let you know how you want to do that, and then you can move on. Any questions, please let us know.